Hello guys, welcome back to the second part of our Python tutorial. In this video, we shall be starting with the Python string methods. Um, String methods are basically used to um, do some work on strings. And as I explained earlier in our previous video, strings are combination of characters or what we can call alphanumerical data. We can use string to form sentences or statements. The first one we'll be looking at is the capitalized method. The capitalized method converts the first character to uppercase. Just as this example you can see here, we have a variable text with value of hello, and right here we are printing the text which is hello dot capitalize, and this is what we would have. Let's dive into our editor. Now let's look at some of the string methods like the upper, the capitalize, the lower, title, and so on. Let's see what we can get out of it. So let's run this Python file with Python main.py. Sorry, main.py. And we can see that on the upper we have all the letters, all the characters in capital, while on the lower we have all the characters in lowercase. On the title, we convert them into title characters. Title character is where you have the first word of every of the first letter of all the words in a sentence in capital letters. So that's just what this one gives us. And then the dot capitalize is going to convert the first letter of the first word into a capital letter, and so many other string methods that we can look at. But right now we are not going to be looking at all of them, but I will advise, if you can go to W3 school, go to W3 school and you would see a lot of them like capitalize, case fold, center, count, encode, end with, expand tab, find, format, and so on. There are many of them that you can look at, and once you click on each one, let's say for example we want to see what a particular string method does, like let's see the center, you click on it and you would see some example, and you click on the try it yourself, and this is what you will see. So this is just how the W3 school looks like, so you can just test it out yourself. Alright guys, if this is the first time you are coming through this channel, please do well to click on the subscription button and hit on the notification bell to get notified whenever we make a new video. Share this video with your friends and comment, like, and share with your friends. Thank you. Let's get on with our training. Now let's look at the Boolean. Let me actually um, snooze this. Okay. Right now, booleans are used to make decisions on whether something is true or false. So boolean basically return two values which are true and false, and we use them in making decisions. So let's say, for example, we have two variables. We have the variable and y3, and we have another variable which is x, and it is 5. We can actually say that y is greater than x, and we can print this statement. Print y is greater than x. Sorry, y is greater than x. If we run this code, it returned false. And the reason why this is returning false is because 3 is not greater than 5, but rather 5 is greater than 3. But if we do this way and say that y is less than x, this is going to return true. And this is what Boolean does. So Boolean returns true or false in a logical manner, which we also use to conduct or carry out logical reasoning in our program and make decisions along the line. There are a lot of things that you can still do with the booleans, but right now let us just look at one more example. We can have that let's have name, and we say that name is a member, and then we have new member, and we say new member. In this case, we can print that. So let's look at the number, or let's count the number of characters in the name and compare it with the number of characters in the new member. So we can actually do that. The length of name is equal to, so we use the double equal sign to signify equality, is equals length of new member. And let's run this code, and you can see we returned false. But if for any case we have the two of them as the same, and we run this code again, we returned true. Because actually, if we are trying to know the length of name, the length of name is going to return 6, which means 6 characters make up this name. Let's look at it. 1, 2, 3, 4, 5, and 6. And the same thing goes here. So we can actually compare them, the both of them, and see if they are the same. So this is the second example that we can look at. There are so many other examples, but let us just stick to this. Let's look at the Python operators. So operators are used to perform operations on variables and value. We use them to actually do operations like arithmetics, do calculations, make decisions, and so many other things that we can use operators to do. And if you come down to W3 school, around this area, Python operators, you would see that Python divides the operators in the following groups. We have the arithmetic operators, the assignment operators, the comparison operators, the logical operators, identity operators, membership operators, and bitwise operators. Now, for the arithmetic operators, we use them to do mathematical calculations. So take that you want to run any mathematical operation, what we use is the arithmetic operators. And for the assignment operators, we have been seeing it right from the onset of this tutorial. The assignment operators are used to assign values to variables and constants or any other thing, but they are used to assign variables. For the comparison operators, we use them to compare between two or more values. For the logical operators, it's basically for logic. The identity operators, we use it to identify a particular group of items or data. Membership operators, we use them to identify whether a value or a variable or a data belongs to a particular group of data or is a member of a particular data. And then the bitwise operator is the one that converts our values into bits or binary. Okay, so we look into them one after the other. Let's start with the arithmetic operator. Just like I said, arithmetic operators are used with numerical values to perform common mathematical operations. So we have the plus operator, which we use, which is called the addition operator. So you basically use it to sum up values. And then you have the subtraction, you have the asterisk, which represents multiplication, you have the forward slash, which represents the division, you have the percentage sign, which represents modulus, and modulus represents remainder, and then the double asterisk, which represents exponential, that's raised to power, and then double forward slash, which is used to floor a number. Flooring means to reduce to maybe the lowest decimal place or lowest whole number, and so on. So we look into that right now. So sorry. Let's start by calculating the the common simple interest of a particular person. So let's just make a comment. All right, so we have this question. A man deposited $500 at an annual interest of 15% per year, annual interest of 15% for 7 years. What is his interest accrued over the years? So first thing is the month's principal amount. So principal underscore, let's use next case amount. Principal amount is 500, and the interest rate, so let's call it rates, is or rather let's make our code readable. So let's just call it interest underscore rate is 15%, and then time is 7 years, and then what we are looking for is interest. So what is going to be the interest? And we know the formula for simple interest, right? So the formula is principal times time times rate, which is the interest rate, all divided by 100. So this is the formula for calculating the simple interest. All right, so let's run this calculation right now, and we are getting that his interest is going to be $6. So he is going to be making $6. Oh, sorry, we need to print the interest. We need to print the interest right now, and let's run this code. Okay, so his interest is going to be $525 dollars. So that is his interest. All right, guys, let's do one more calculation on this. You know, this may look a little bit complicated, so let's do something simple. So um, we have x is equal to is assigned to 45, and we have y is let's say 67, and we have the result is, let's do addition, is x plus y. In this case, if we print the result, and we run this code, we are having that the result is 112, which is actually correct. We can also subtract and run the result again, and we have minus 22. We can do that of multiplication, which is asterisk, and if we run this code, we have 3015. And you can also do double asterisk to make it a raised to power. So let's change this to 2 and do something that we can understand. So 2 raised to power of 3 is going to be 2 times 2, 4, 4 times 2, 8. Is going to be 8. So the result should be 8. All right. Okay, so right now, let's have 5 here, and let's divide and find the remainder between when 3 divides 5, what should be the remainder? The remainder is going to be 2. So let's use the modulus sign here and find the result, and this is going to give us 2. The same thing if we want to divide 5 by 3. It's supposed to give us 1.67, and but if we do floor, which is double forward slash, then this is going to return 1, which is it is going to return the whole number part of it, which we have the result as this is supposed to be 1.667 or 1.67 or thereabout, but then flooring it makes you to reject the fractional part or the decimal part and only take the integer part or the whole number part, and that is what this does. Now, looking at the assignment operator, let's see how the assignment operators work. Let's say we have age is 34 and we want to print age. In this case, this equality sign you are seeing right here is an assignment operator. If we run this, you already know this is supposed to give us 34. But there are so many other ways we can still assign an operator. For example, we can have age right here and say that this age is 30. And right here, we come here and say this is going to be age. Let's see. We have 64. Now this is assignment operator. But right here, what we are doing is that since we have an initial value of 30 and we have age plus equals 30, this adds or increments that variable into with whatever number or value that you have here. If we have as plus equals 1, this is going to give us 31. So we can also decrement this with the minus sign, and in that case, if we run, you can see it decrements it by 1. We can also decrement by 4, that's going to give us 26. As we can see here, we are having 26. These are some of the assignment operators. You can do more with this. So all the arithmetic operators that you've seen before, we can still use them just to assign a value outside of the box. So we can also have the modulus, and that's going to give us 2, and so on. So this is what assignment operators can look like. Now I'm going to give you a class work. You are 19 years old now. How old were you 6 years ago? All right. Pause this video and do this work. Let's solve this. So your age is 19. So 6 years ago, you would be age minus equals 6. So let's use the template literal, and right here we can say let's use template literal like this. So let's say you were age years old, 6 years ago. So let's see what we have. So you were 13 years old 6 years ago. So this is what assignment operators can look like in real life. Now let's look at comparison operators. So for the comparison operators, like I explained earlier, we use them to compare between two or more values. Basically, when we are comparing two or more values, we are returning Boolean values. All right, let's see it in action. So we have age of X, and we also have age of Y. For the age of X, it is 45, but for the age of Y, it is 35. And we want to compare. So we can say print age of X is less than age of Y. Now, let's see the result. Age of X is 45, while age of Y is 35. So age of X should be greater than age of Y. So which makes this particular statement false. Let's see. We are returning false. Let's clear this screen so that we can know what we're doing. But in a case we say is greater, then it will return true. If we run the code, you can see we are returning true. We can also run is less than or equals this, which will also return false because it is not equal. But what if we have 45 and 45 and we say is less than? It's going to return false. But if we do is less than and equal to, now what we do, what we are actually comparing here is we check if this is less than this, and then we check if it is equals. So in that case, it's going to return true. Okay, so what if we have this as 40 and then we have this as greater than? So 45 is greater than 40, so X is greater than Y. So we are going to return true. Well, if we have is greater than or equals, still going to return true. But if we try to say that they are equal, it's going to return false because they are not. But if we say that is not equal, they are not actually equal. So this is going to return false. Sorry, true. Because this and this are not equal. So the statement is true. But what if we have them as equal? The statement is going to return false. So this is what comparison operators can do. And you can see right here that the only value that comparison operators return are always Boolean values. Now let's look at the logical operators. So the logical operators are the and, or, and not. So like I said before, what they do is that they carry out logical operations on our code. They look at our variables or our data and logically analyze them. So let's have x is 5 and we say print. And what we want to print here is that x is greater than 3, which is true actually, because if you run this code, it's supposed to give us true. And so, and here is going to make sure that the both side of the comparison are all true. If they are all true, then it's going to return true. But if one is false, it is going to return false, whether or not the other one is true. It may not make sense, but let me show you. So we have x is, let's say, less than 10. So in this case, x, which is 5, is greater than 3 is true, and then x, which is 5, is less than 10, which is true. So the and here is combining these two expressions. This is the expression 1 and this is expression 2, and this and here is combining the both of them and trying to look into them and making sure that it maintains a strict comparison between these two expressions. So this must return true as well as this must return true before we get true. But if this returns true and this returns false, then we get false. If this returns false and this returns true, we get false. So for it to return true, the two expressions must return true. That is what and does. So let's see. We have true. But in a case where we have 6 here, we all know that 5 is not greater than 6. So this is false, whereas this is true. So in this case, it is going to return false. And we have false. So this is what the AND operator does. I know it may not fully make sense to you, but when you try to solve problems around it, you begin to understand it. So just know that x and the two expressions must always return true for the expression to be true. But if one returns false and the other is true, then it is going to return false. That is AND operator. But what about the OR operator? So for the OR operator, if one of the expression is true and the other is false, it is true, it is going to return true. If the both of them are true, it is also going to return true. But if both of them are false, it is going to return false. So in this case, OR is an opposite of AND. AND returns true when the both expressions are true, but OR returns true when even one of the expression is false. So let's see. It is returning true. And if you look here, this is false. But because this is true, it is going to return true. If this is also true, because you know this is true and this is true, it is still going to return true. But in a case where both of them are false, it is going to now return false. So that's how the OR operator works. And for the not operator is a little bit trickish in the sense that this is true and this is true. And for us to use not, we use not like this, not, and then we can pass in this. And you know that this is true and this is true. But because we are using not, this is going to return false. Why? All right, so let's look at it logically. So not is always returning a negative of what the value of the expression is. So if we have an expression here, and you know that this expression x is greater than 1, which is true, or x is greater than um, 10, or x is less than 10, which is also true. So ordinarily, these two expressions is going to return true. So if we are using not, it's going to give us a negative of whatever value we are getting. So since we are getting true from here and we are using not, we're going to have false. But if we have and here, we all know that this is true and this is also true. So it is still going to give us false. But if one is false, like this, if one is false and we are using and, you know, this is supposed to give us false. So the negative of false is supposed to be true. So this is supposed to give us true. So this is just what the logical operators do. It may not really make sense to you, but this is just logic. Okay, just application of logic into your programming sense. That's just what the logical operators can do. You can find out more examples from W3 schools, or you can reach out to me if you didn't fully understand the logical operator or any other part of this video. Please use the comment section. Tell me that part of this video that you find it difficult to understand, and I'm going to make a video to explain that particular concept properly to you. Remember, if you have not subscribed to this channel, you are not doing good. You really need to subscribe and support the channel to grow, because it is your support that encourages me to do more videos. So make sure you subscribe and like the video so that the YouTube algorithm can rate the video higher. So you really need to participate. Share this link, the video link, to your friends so that they can join the channel. Let's proceed. Now let's look at the membership operators. So the membership operators actually, they look at whether or not two or more variables are of the same members. So let's try and have, okay, let's do this. Let's have fruit variable, and this is going to be a list of fruits. So let's have apple, cherry, cherry, apple, cherry, and almond. Let's also have another variable for food, and that's going to also be a list of Let's just copy what we have here and paste it here. Now let's print that fruit is food. Now in this case, so many of you might think that this is going to return true, but this is actually going to return false. And the reason being that even though the value of fruit is the same thing as the value of food, they are of different objects. So this is going to return false. Oh, what am I running? What am I running? Python main.py, please. So this is returning false. Why? Because even though they have the same content, they are of different variables, or they are of different data. They are not the same object. But if we say that fruit, or rather, if we say that vitamin, let's say vitamin is is fruit. So we are now assigning fruit to be vitamin. And in this case, if we say that fruit is vitamin, this is going to return true because they are of the same object. Let's see. We are seeing true. So, and we cannot also say that food is vitamin, even though they also have the same value. So look at it, it is returning false. So the is checking to see if the two data are of the same object. If they are of the same object, then it returns true. But if they are not of the same object, it will return false. And that is also applicable to is not. So is not is going to return true if they are not of the same object. For instance, for food is not fruit. So food is supposed to return false because they are not. But if we use is not, then it should return true, which is this. So you can see that Python code is readable. It is close to the English language because when you look at this, food is not fruit. So it really made sense in ordinary sentence. So it is not that too difficult to understand. So looking at bitwise operator, I am not going to do much on the bitwise operator, but if you want me to make a full video on bitwise operator, leave a comment in the comment section so that I can see that you are interested in learning more about the bitwise operator. So, but what is bitwise operator and what is it used for? So bitwise operator is used to convert numbers or convert values into binary numbers. And binary numbers, as you all know, are 0 and 1. Binary number contains only two digits, which are 0 and 1. So we have the AND, the NOR, the XOR, and so on, so many of them, but I'm just going to look at the bitwise AND. So we either use the ampersand symbol or we can use this AND. But I'm going to use the ampersand. Now, this is going to return 2. Let's see. And our answer is 2. So this is bitwise operator. It's not going to make sense to you, but if you want it to make sense to you, subscribe to this channel and use the comment section to tell me that you are interested in learning more about the bitwise operator, and I'm going to do a dedicated video only for the bitwise operators. So let's go on to the next module. Let's look at the Python arrays, or what we can call data structure. We still look at Python data structure and algorithm, but for now, let's just call it Python arrays. If you are transitioning from any other programming language like JavaScript into Python, you would know what arrays are. If you are transitioning from PHP, from JavaScript, from all these other high-level programming languages into Python, you would know what arrays are used for and what they are. Arrays collect multiple values or multiple members for one variable. So you may want to have a particular variable and you want to use it to collect multiple values. For instance, you want to have a list of students, and you can continue creating variables like student 1, student 2, student 3, student 4, and so on. What if you have 100 students, you create student 100, and so on. So it makes everything difficult. So when you use arrays, you are creating just students, and then you now use that particular variable called student to collect the hundreds of or thousands or millions of the students, and you can easily return each of the students when needed. And that is what arrays are. In Python, we don't call them arrays, but Python divides them into 4 different data structures, starting from list. A list is a collection of data that is changeable, that can accept duplicate values, and also that can be what we can call arranged. Okay, so let's, for example, we have a list of fruits. So let's call this fruit. And this is a list of fruits. This is what a list looks like. Let's see. Print. Let's know the type. Type. Let's pass in the fruit and run this code. And we are getting class list. And this is because this is a list. What if we have the same thing, let's say fruits, but this time around we cover everything in a bracket or parenthesis, and then we copy all these things. In this case, this is tuple. Let's try. You can see that this is a tuple. I will later on in this course tell you why you need a list over a tuple and why you need a tuple over a list. Each of them has their strength and their weaknesses. So when making use of each one, you must have to understand why you are using any of them. For instance, between the list and the tuple, the list and the tuple are indexed, But one difference between them is that you can change item in the list. Sorry. For example, in a case where I have apple as the first member of this list, I can reassign it this way, fruit. And then I will target the first index, which is going to be 0, and I'm going to change it to almond. And in this case, if I go ahead and print fruit, I now have almond, banana, and cherry. So I have replaced apple with almond. That's the list. You can change items in a list. But can we do the same for a tuple? Let's see. Let's try and print this tuple. We get an error, and the error says type error. So we have to take note of the error. And the type error means that the type of data you are trying to access is not accessible, or whatever you're doing, you are not getting the type of data properly. And if you read more, you see where the error is coming from, where we reassigned a value to a tuple. And if you read the type error very well, it says tuple object does not support item assignment. So you cannot reassign an item in a tuple. That is one difference between the tuple and the list. So if you want to take in data that you want to make sure that they are strict, that they don't change throughout the code, then you should apply it as a tuple. You should use it as a tuple. But if you have a set of data that you want to change, or you want to leave it flexible, then you should use a list. That's the difference between a list and a tuple. Now let's look at how to access a list and a tuple. How do we access a list? How do we access a tuple? The both of them remains the same. The way we access a list is also the way we access a tuple. So if you want to access a list, we use index. For instance, for this apple, we have it as index of 0. This is index of 1. This is index of 2. So the first value of every array or of every list or tuple is index 0. The second member should be 1, and so on, if you have, depending on number of values that you have. But just know that it starts from 0. So the index value is going to start from 0. All right, so if we want to print banana, for instance, from the fruit, then instead of printing fruit, if we print fruit, it's going to give us everything in the list. But instead of printing fruit to get everything in the list, what we will do is we are going to now set it that use this block bracket or square bracket and select the index value of the data that we want to print. And in this case, if we print this, it's going to give us apple because this is index of 0. If you want to get banana, it's going to be 1. And if you run the code again, you get banana. If you want to get cherry, and so on. That's how it works. If you want to get the two of them, you can just say fruit 1. And you can run this code and you have banana, banana. You can print the third member, which is going to be 2 index, and if you run it, you get banana cherry. So this is just how we can return all the items from a list or even from a tuple. Let's try that in a tuple. You can see we can return them. So this is the tuple, which is the fruits, and this is the list, which is the fruit. And you can see everything is still working perfectly. That's how to access items in a list or a tuple. Both of them have the same method. Again, a list can also take different types of data. Let's say integer data and even Boolean data. And if we try running this code, nothing gets wrong. Same thing, this. Let's try running this again. Everything is fine. So both the list and the tuple can accept different types of data in the same list. So you can see these are strings, this is integer, and this is Boolean, all in the same list. Same thing here. These are strings and this is integer, still working perfectly as a list and a tuple. They are ordered. All right. We can also access a list from the back, or what you can call reverse. Let's try printing this list from the back. In this case, we can use negative. And you can see we are getting true. So -1, we don't have -0. 0 is 0. But -1 is going to start from here and loop all the way like this. While if we are using positive, it starts from 0 down to this part. We can also just return from a set of value to a particular value and end. So let's see how we can do that. In that case, let's say we want to print from 0 to the third value. So in this case, we are starting from 0, and that's why we have index of 0, which is apple, and then we want to make sure we count 3 data. So in this case, we are going to return apple, banana, and cherry. Let's see what it gives us. We have apple, banana, and cherry without printing these ones. If we make it 4, and run this code, you can see we are returning 34 as well. So in this case, this is where it starts, and this is how many data it returns. Very simple, right? That's just it. We can also return the length or the number of items in a list. And in this case, we are going to use the length function, and we are going to pass in the fruit. If we run this, we have it that we have just 5 data, which is true. 1, 2, 3, 4, and 5. So we have 5 data. But we can still get the number of characters that make up one particular item in the list. For instance, the apple. if we want to know the number of characters that make up apple, in this case, this is 1, 2, 3, 4, and 5. So we can still do this with the square bracket and index of 0. So length of apple we are assessing right now, it gives us 5. For the banana, we should have 6. So let's change banana, which is index of 1. Run the code again, we have 6. So there are a lot of things that we can still do to this. And for any reason you want to convert a list to a tuple, or rather you want to convert a tuple to a list. So let me convert this to a tuple. So this is a tuple right now, and you know it still works perfectly. Nothing is wrong. But in a case you want to convert a tuple to a list, how do we do that? So in that case, we use a tuple constructor. So we can just reassign this fruit is, and then we just say list. And you can pass in your fruit here. In this case, we have converted this fruit, which is a tuple, into a list. And always remember to end your tuple with a comma. And you can see everything is still working, but right now, if we do type and pass in the fruit, we get it as a list, even though it is a tuple right here. You can see it's a tuple from right here by just, let's say, print and print the type of fruit. We run it. At the top here, we have tuple, which is, but right here, we have list. And that's what the list constructor can do. You can still do that in a case where you want to convert a list to a tuple. In that case, you use the tuple constructor, which is tuple. So this is the tuple constructor you can still use to make sure you convert it to tuple. And you can see we have the both of them as tuples. So you can either convert to a list, or you can convert to a tuple, list to tuple, tuple to list, whichever one. But why are we converting a list to a tuple and a tuple to a list? In a case where you have a tuple and you know that tuple has this strict method which holds the data and make sure that the data are not changed. In a case where you have a tuple and you want to really change something in that tuple, in that case you have to first of all convert it to a list and then reassign a value to it and convert it back to a tuple. It's just what we can do with that. So let's say, for example, here we have a tuple and you know we cannot change maybe the value of true to false. In that case, we have to convert this tuple into a list. And after converting it to a list, we can now do something like this, fruit, and then we target the index value of true, which in this case is going to be -1, since I don't want to suffer myself trying to find the index, but the index is going to be 0, 1, 2, 3, and 4. So if you still want to use 4, you can still access it. Okay, and I want to change it to false, and then print fruit and convert it back to tuple. So you can do fruit is tuple, and then we pass in fruit. Very simple. Let's clear this first, and then let's run this code. And we can see at the top here where we have the tuple, this is tuple. Then down here, this converts this tuple to a list, and then reassigned true to false, and prints the fruit, and then convert it back to tuple and prints the type tuple. And that's what you're seeing right here. So everything is possible. Can convert a tuple to a list, can convert. So when you have a list and you want to maintain a strict data, that you want that data not to change anyhow, you can still convert that into a tuple. So it doesn't matter what you want to do with it. You just have to think programmatically to make decisions for yourself. That's just what this can be used for. We can also add another value into a list using a special method, or what we can call a list method, like this: fruit dot append, and let's append orange, and let's print fruit. And you can see orange has been added. So we can still add into an existing list. But we can't do that in a tuple, right? Because a tuple cannot accept an additional member, except you convert it to a list and then put up a new member and then convert it back into a tuple. That's just how you can do that. But a list can accept extra additional values. So in the append, you notice that it only adds to the back of the list. But what if we want to specify where we want to add our new value? Let's say we want that new value to be the first member, or maybe to be the middle member, or maybe to be the last member. How can we do that? In that case, we then use the .insert method. And the insert method is taking two positional arguments. One is the position, or the index position, where you want it to be. So if we want it to be the first member, and the first member is going to be index of 0, in that case, the first position, the 0 here represents the position where we want this orange to be, and then we are printing this. So if we print this, what we will now have is orange, apple, banana, cherry, 34, and true. Let's see what we get. You can now see orange is the first member, while apple, banana follows up. And that's because we specified the index. If we say that the index is going to be 3, in this case, this is 0, 1, 2, and 3. So it's going to appear at the middle between this and this. Let's see. You can see orange appears at the middle between cherry and 34. It has taken the index of 3. That is what the .insert method does. So, but in a case where we have two lists that we want to join together, in that case, we are going to use this special method. So let's say we want to join food to fruit. In this case, it's going to be fruit dot extend, and what we want to extend to this is food. So we want to extend food into food. In this case, let's just print this. Let's print this. You can see that this gives us none. Now let's see one more thing. Let's come down here and print fruit. So you see the magic. You can see at the top here we have none, but here we have the both of them joined together. So sometimes when you see something like this, it doesn't make sense, because actually what we have here may look like it is exactly what we have here, but that's not true, because what we have here is that we have merged everything here and everything here, and they are now fruit. But right here, there is no variable you are printing, so this returns none. So you have to be careful most times when you are doing something like this. You can also use for loop, but I just don't want to start talking about loops because that will be in our next class. But you can still use loops throughout this to iter throughout the members of this list. So right now that we have extended the fruit to the food, and we have the food as the fruit with all these things. If we come to for loop and use for, let's say for fruit, or sorry, for item, let's use item in fruit, and then we want to print the item. In this case, I'm going to remove this one, or rather, let's just say fruit dot extend food, and you can see we are printing them one after the other. So this is, you can still use for loop, while loop. You know, Python has only for loop and while loop. So these two loops can still be made use of in lists and tuples. So, guys, I want you to solve this question. What is a correct syntax for looping through the item of a list? Look at this. For x in this, then print x. We also have for x in this, print x. Now, what's the difference between this? For x in this list, print x. For x in this list, print x for each. So what is a correct syntax for looping through the item of a list? Leave your answer in the comment section. We will see in our next episode. Thank you for being here. Make sure you subscribe to this channel and hit on the notification bell. Share this link, like the video to support the channel. I will see you in our next module. Thank you.